Okay, I go back and pick up a little bit from section 6.6 and then go on and do some in chapter 11, and it's all about solving quadratics. Now, there are several ways that we're going to look at for solving quadratics. The first way is factoring. That's going to be review from section 6.6. We've used it all semester. The second way is rather specific to only certain kinds of problems, and it's called the square root property. The third method for solving quadratics, and by the way, the square root property is in section 11.1. Also in section 11.1 is a process called completing the square. The nice thing about completing the square is that it's a process can be used to solve any quadratic. The bad news about completing the square is that it's a very tedious process. Number 4, there's also a formula. It's called the quadratic formula. And it also can be used to solve any quadratic, and it is much friendlier than completing the square. But we will go ahead and go over both of them. All right, so let's go ahead and review section 6.6. Let me make this a little larger. Okay, so I hope that I don't say anything that's new to you in the review. Yay, it's white. In 6.6. Oh, back to blue. All right, it asks us in problem number 1 to solve the equation x minus 7 in parentheses times x plus 1 equals 0. Now this problem would be quadratic. You would see it as quadratic if it were multiplied out, and it's already set equal to 0. It's already factored, so all you have to use is the zero factor property that says either x minus 7 is equal to 0 or x plus 1 is equal to 0, which means x is 7 or x is negative 1. So that should come as no surprise. Problem number 2 is just like that. I think we'll just skip it. It's a little bit more practice for you in my math lab. And let's go down to number 3. It asks you to solve the equation x times x plus 1 is equal to 0. Once again, it's quadratic. That would be very obvious if it had been multiplied out, but it's already been factored. In this one, there must have been a common factor of x. So you would have x equals 0 or x plus 1 equals 0. Now this is already a solution, that common factor, and this one would tell you x is negative 1. So problem number 3 has already been factored, already set equal to 0, so everything was easy there. Problem number 4, very, very much like 3. So I think we'll skip that one. Let's go to problem number 5. And I'm going through this part quickly because this should all be review. Once again, already factored. It has 4x minus 8 times 9x plus 1 equals 0. And the reason this problem is in there is because the factors here are a little more complicated, so the answers might not be as easily apparent. I know that 4x minus 8 equals 0 or 9x plus 1 equals 0. The first equation, it's a little bitty linear equation, so I would add 8 to both sides, so I get 4x is equal to 8. divide by 4, and x is equal to 2. But the other problem, I'll subtract 1, and I get 9x is equal to negative 1, divide by 9, and x is equal to the fraction negative 1/9. Whoops. So sometimes we will get fractional values, sometimes there's a little bit of work to solving the equations. All right, number 6. I'm going to skip down here and do it. Get myself a little bit of room. I'll make this visible to the class in just a second. But we're going to solve x squared minus 12x plus 20 equals 0. All right, so for the first problem in this lesson, I actually have to do the factoring. It's quadratic, it's equal to 0, so we're ready to go. It's a trinomial. I go to trial and error. What about the signs? Okay, if the last one's plus, they're both minus. Okay, so we want to be careful about that. So I have x and x. I need factors of 20 that add up to be 12. All right, 2 and 10, in whatever order you want to write those. Now I use that zero factor property. X minus 2 is 0, or x minus 10 is 0. That means x is 2, or x is 10. And although I usually don't take time to check those, you could put either value in for x and it would make a true statement. No such thing as extraneous solutions when you're just solving regular quadratic equations. Problem number 7. Let me go back and see it. It's x squared plus 3x minus 18 equals 0. Okay, would you take a minute to solve that quadratic? All right, it is quadratic. It is set equal to 0, so it's ready. It's a trinomial, so I go with trial and error. The signs, what are the signs? One of each, because the last sign is negative. So I need an x and an x. I need factors of 18 that have a difference of 3. 6 and 3, I'll make the 6 the positive and the 3 the negative. Using the zero factor property, x plus 6 is 0, or x minus 3 is 0, which means x is negative 6, or x is positive 3. And you are welcome to skip as many steps as you feel comfortable skipping at this point. Everybody okay? Probably a little bit boring. All right, problem number 8. It says solve the quadratic, and let's see how much room I have. I have x squared minus 3x equals 18. It is quadratic, but it's not equal to 0. So I'm not ready to do the factoring. I will first subtract 18 from both sides and get x squared minus 3x minus 18 equals 0. And this is very, very similar to the problem I just finished factoring. I'm going to have 1 plus and 1 minus, an x and an x. Once again, I need factors of 18 with a difference of 3, so it's 6 and 3 again, but this time the 6 goes in the negative and the 3 in the positive. So if I skip a step, would y'all agree that x is negative 3 or x is positive 6? Is everybody okay with that? I just skipped the step where I set them equal to 0. Okay, problem number 9. Didn't leave a lot of room for this. I have x squared equals 1. Now, in a few minutes, I'm going to show an alternate way to solve this problem. But for right now, the only tool we have is factoring. It is quadratic, but it's not equal to 0, so I'll subtract 1, and I get x squared minus 1 is equal to 0. Now, can I factor that binomial? Is it anything I'm familiar with? Difference of squares? Difference of squares factors into x plus 1 and x minus 1 because the square root of 1 is 1. And that gives me x is negative 1 or x is positive 1. And like I said, in a few minutes, I'm going to talk about an alternate way to think about that problem. But for right now, I treated it as the difference of squares. All right, problem number 10 has x minus 3 times x minus 6 is equal to 2x. Now I think you can tell, even though it's factored on the left-hand side, that it would be quadratic because it would have an x times an x. But it's not equal to 0. So these factors are useless. What can I do to get rid of the factors? FOIL. I can multiply that out. So if I multiply this out, because these factors are useless since I don't have a 0. So the product of the first is x squared. The outer product is negative 6x. The inner product is negative 3x, which makes negative 9x. The product of the last gives me plus 18, and that's equal to 2x. Is everybody okay with the result of using FOIL? Now I've got to get the 0, so I'm going to, subtract 2x from both sides. And that's going to give me x squared minus 11x plus 18 is equal to 0. Now it's ready to factor. I'm going to have a minus and a minus. I need an x and an x. I need factors of 18 that add up to be 11. 9 and 2. That means that, and I'm going to skip a step, x is 9 or x is 2. So this problem just points out the fact that the factors are not useful unless it's equal to 0. The same thing happens in problem number 11, so I'm going to skip that one for now. And I'm going to go to problem 12, which I think maybe is our last factoring problem. And we have x cubed minus 13x squared plus 40x is equal to 0. Now this one is not quadratic, it's cubic because of the power of 3, but I'm still going to try to use factoring. It is equal to 0. First thing, do you see a common factor of x? So I have x times, factor an x out, that'll leave me with x squared minus 13x plus 40 is equal to 0. Keep the x, factor the trinomial, last sign is positive, which means what? Both are negative. Need an x and an x. I need factors of 40 that add up to be 13, 8 and 5. Now I'm going to go ahead and show the steps. I have 3 factors this time. So the zero factor property says x is 0, or x minus 8 is 0, or x minus 5 is 0. X equals 0 is an answer. X equals 8 is an answer. X equals 5 is an answer. Is that okay? Just a quick review of factoring. We went through and did quite a few different problems. Okay, and those are just the answers. All right.